Okay. Now, so guys, again, very good morning. This is Sanjay Rathi, Network Theory, Network Theorems, question practice. Okay. So first of all, what are the questions, important questions from standard textbook? We will discuss Thevenin's theorem, Norton's theorem, maximum power transfer theorem, with what independent sources and with what dependent sources here. Okay, I think all are ready. Now, this is my introduction. Myself Sanjay Rathi, 24 years of teaching experience. I have qualified and selected for engineering services exam. These are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008, and I have trained more than 1 lakh students for these competitive exams, guys. Okay, अब क्या मिशन है कि आप जितनी ज्यादा क्वेश्चन प्रैक्टिस करेंगे, प्रीवियस ईयर क्वेश्चन सॉल्व करेंगे, आफ्टर गेटिंग द कमांड ओवर थ्योरी, डेफिनेटली यू कैन क्लियर एनी टाइप ऑफ कॉम्पिटिटिव एग्जाम्स, गाइस. ओके, अब आते हैं जरा. दिस इज माय टेलीग्राम चैनल. तो न्यू स्टूडेंट्स, यू कैन ज्वाइन माय टेलीग्राम चैनल इलेक्ट्रॉनिक्स बाय संजय राठी, और होप ऑलरेडी यू हैव डाउनलोड द ऐप. अदरवाइज डाउनलोड द ऐप, link is given in description. Now that is the first question. Just I will give you the hint about the superposition theorem, that for the circuit in figure, use the superposition theorem to find I. Suppose you are watching the recorded lecture, right? If suppose you are watching the recorded lectures, then what you can do, first of all, pause the video, try to solve it, and then go for what solution. Is it clear? Pause the video, try to solve this question on copy with virtual calculator, and then go for solution. If you are getting the right answer, then it will boost your confidence. If suppose you are doing some silly mistakes, you can avoid in next question. Or if suppose you have no idea about the concept, then suppose you are able to solve 50% to 60%, then again it will boost your confidence, and then go through the solution. You will get new idea how to approach this type of questions. Okay, then for the circuit in figure, use the superposition theorem to find I. Now, superposition theorem if you want to use, then always remember there are three. Normally in GATE, they are asking theoretical question on superposition theorem, because it is a very lengthy to solve this type of questions. But just I am giving you the hint. For the circuit in figure, use the superposition. So there are three sources: first, second, and what third. So what you can do, remember, one by one you have to consider the three sources. Like this is the first source, this is the second one, and like this is the third one. Now I is due to 12 volt battery, due to 24 volt, and due to 3 ampere current source we have to find. Then I, you can write I1 due to 12 volt battery, I2 due to 24 volt battery, and I3 due to 3 ampere current source. Now when we are considering the first, second, and third, to one by one. For example, if you are going to consider the 12 volt, then make the 24 volt 0, 3 ampere 0. How we can make the 0? Current source open circuit if you want to make it 0. Voltage source short circuit if you want to make it 0. So one by one you have to solve this question 3 times. Okay, very good morning everyone. Now one by one we will solve. So what is the answer for this question? That was the assignment. Now first of all, consider the 12 volt battery. If you are going to consider the 12 volt battery, then make it 0, open circuit. Make it 0. This is what? Open circuit. Now what about this? This will act as what? Short circuit. This 24 volt battery will act as short circuit, guys. We have to find the current due to 12 volt. Okay, now what about this 4 and 8? This 4 and 8 are in series, so it will become 12. and this is the 12 volt battery. This is I1, or this is connected in a parallel. This is connected between A and B, right? So 4 and 8, that is the 12. 12 and 4 are in parallel, means what is the parallel combination? 3. 3. This is the 12 volt battery. Now guys, you can calculate the I1. This is 3, this is 3, this is 12. So what is the I1? 12 divided by 6, that is the 2 ampere. 2 ampere because of first battery. Okay, because of the first battery, it is a 2 ampere. So what we have done, make the current source open circuit, make the voltage source short circuit. 4 and 8 are in series. 12 parallel with 4, that will become 3. Then 3 and 3 are in series, so R equivalent is 6. 12 divided by 6, so what is the I1? I1 is what? 2 ampere. That is the first question. First battery, because of that 12 volt battery. Now, first, because of the second one. Second one is a 24 volt battery. So you can make it what? Again open circuit. Make it open circuit. Make it short circuit. Which one? 12 volt battery. Short circuit. This time this is short circuited. And you have to find this I2. This I2. Right? Now, watch this. This 3 ohm is parallel. This is let A. This will become A. Let this is B. So, these 8 and 4 are in series. So, that has become the 12 with 24 volt battery. And then 4 and 3 are in what? Parallel. Redraw the diagram. Okay. This is B, this is A, and this is I2. 4. Then 24 volt battery, and that is 12. 8, 4, 12. Okay, 8 plus 4, 12. Now, this is the combination, and you have to find the I2, and this is the 24 volt battery. 24 volt battery. Tell me what is the value of the I2, positive or negative? Positive or negative? First, give me comments. देखो डायग्राम हो गया. Get the command over KCL, KVL और mass analysis, nodal analysis. You can solve this question by various ways. Okay, no problem. Kamini, please try to solve this question. Yes, now your comments are visible to me. Then, first of all, you can find a R equivalent, and then you can find the current, and then you can use what? Current division rule. That is one way. Or what you can do, you can convert the voltage source into current source. For example, I am going to convert this voltage source into current source. Then 24 divided by 2, it will become 12 ampere. 24 divided by 12, so it will become 2 ampere. Sorry, not 12, 2 ampere. And what is the direction of the current? This side. And this is the 12 that is in parallel. Now this voltage source is converted into current source across A and B. This is A, this is B. Now this is a 12, this is 4, and this is 3. Now what is the parallel combination of 12 and 4? 3. Three and 3 are in parallel. That's why this current is divided into 2 equal parts. This will become 1 ampere, this will become 1 ampere. Now, but we want I2. What is the direction of the I2 and I1? Opposite. And that's why I2 is equal to what? Minus 1 ampere. I2 is equal to minus 1 ampere. Easy. So what is the effect of the 24 volt battery? We are getting the negative current. And what is that negative current? minus 1 ampere. minus 1 ampere guys. तो ये आ गया क्वेश्चन में. So we have number of ways to solve this question. You can apply the mesh analysis or what nodal analysis or any other method, but I have just redraw the diagram. That is the 24, 8 plus 4, 12 in series, 4 in parallel 3. Then I have converted the current voltage source into current source, 24 divided by 12, and then 12 parallel with the 4 is what 3. We have idea 3 and 3 are in parallel, and that's why the current is divided into 2 equal parts. Any doubt? If suppose there is a calculation mistake, then you can inform me. That is the method to solve the question. Calculation is aspirants part. Okay. Then अब आ गया because of the first battery 2 ampere, because of the 24 volt battery minus 1 ampere in opposite direction. Now the third, what is the effect of current source? If you want the effect of current source, make it short circuit. Make it short circuit 0, and this will become I3. This will become I3. Now this is A, this is B. ओके अब कैसे निकालोगे बताओ. ये शॉर्ट हो गया तो दिस इज ऑल्सो ए, दिस इज ऑल्सो ए, राइट. नाउ दिस इज चलिए बनाइए, ड्रॉ करो, redraw the diagram, and or any other method you can solve this question. How you are going to get the value of the I3? Easy to easy method. Okay, बोलो जरा. What I can do, I can apply the mesh analysis, or directly I can apply, for example, this is I3, let this is the I, then it will become what? 3 minus I. This is what? I, then it will become 3 minus I. And now what is this? We have to find the I3, na? Remember, this is the I minus I3. I minus I3. Now what is the current in this branch? It will become 3 minus I plus I, 3 minus I3. 3 minus I, this is the plus I, so minus plus cancel out and minus I3, and here I3, so again you will get the 3. That is the 3 ampere. Okay, that is the current division rule. Now you can apply the KVL. So first of all, apply the KVL in this loop. You will get the relation between I and I3, and then you can apply the KVL in this loop. So in this loop KVL, it will become 4 times of I minus I3, 4 times of I minus I3, and then minus 3 times of I3 is equal to 0. Then it will become 4I minus 4I3 minus 3I3. 4 minus 3, that is will become 7, is equal to 0. Okay, that is become 7, that is the 0, and you will get, what is the relation? I is equal to 7 by 4 times of I3. 7 by 4 times of I3. Check my calculation. So what I have done, just this is the current I, and this current will become 3 minus I. Here it will become I minus I3. Then here we are adding the I, so I cancel, and that is the I3, 3 minus I3, right? And then guys, I have just write the KVL to plus 4 times of I minus I3. Then we are moving in this to minus 3 times of I3. Then 4 minus, that is the become the 7, and that is the I, and what is the relation? I is equal to what? 7 by 4 times of I3. Okay. Now second KVL you can write here in this loop here. So or in a clockwise direction or anti-clockwise direction, it's up to you. लेकिन अब right कीजिए. Now this will become 4 times of I minus I3. This is the plus, this is minus, and that's why it will become negative. 8 times of 3 minus I, and then 4 times of I is equal to 0. 4 times of I is equal to 0 up to this point. Now it will become 4I minus 4I3 minus 24 plus 8I plus 4I is equal to 0. Then 4, 8, 4. It will become 16I minus 4I3 is equal to what? 24. And what is the I? I is 7 by 4 times of I3. Minus 4I3 is equal to 24. Then this is the 4, 7 into 4, 28 times of I3 minus 4I3 is equal to 24. So what is this? 24I3 is equal to 24. So what is the I3 is equal to 1 ampere. I3 is equal to what? 1 ampere. This is one way. This is a one way, right? सर 3I minus I3 नहीं होगा क्योंकि ओपन लूप. ओके, व्हाट इज योर डाउट? 3 minus where in this equation or in this equation? Okay, in this equation. Mm-hmm. 3 minus I3, because what is the resistance here? What is the resistance here? Tell me. Is there is any resistance in path, in this path? No resistance. So what is the current moving in a downward direction? I3. What is the branch current in this loop? I3. And what is the branch current here? 3 minus I3. So we are applying the KCL at this point. This I3 is cancelled, and what is the moving here? 3. So what is the branch current here? I3. What is the branch current here? I minus I3. And that's why we are writing 4 times of I minus I3. There is no resistance in this loop, and we are writing here, and that's why it will become minus 3 times of I3. And this is the 4I minus I3 minus 3 times of I3. Now it is clear. This one, equation number 1, equation number 2, equation number 3, 4, 5, then 6, 7, 8, 9, and this is 10. So guys, just I am writing the equation so that you can ask me, sir, problem with this equation. Equation number 1 or 2 or 3 or 4 or 5 or 6 and so on. So I will give the answer for your question. Okay. Sir, loop 1 में. Okay. In loop 1 na? Yes. Now it is clear to you. Okay. 4 times of I. Where is the 3 minus I3? Okay. Clear no? Okay then. Now you will get the 1. Now what about the superposition theorem? Yeah, directly we can solve this question by using what? Mesh analysis or nodal analysis. No need to apply the 3. But superposition will make the question lengthy. 3 times we have done the calculation. 3 times. What type of calculation? First we have made this voltage source 0. Right? Then current source. Then we have find the 2 ampere. Then second we have find the minus 1 ampere. Then we have find the 1 ampere. So what is the total current? I is equal to, first it is 2 ampere, I2 is equal to 1 ampere, or I2 is equal to minus 1 ampere. And what is the I3 is equal to? Again 1 ampere. This 1 cancel, and answer is what? 2 ampere. Answer is 2 ampere. Now for example, if you want to solve this question by mesh analysis, nodal analysis, it will become very easy. How? We can easily solve this type of questions, and we will get the answer in one step. Now watch this. Same logic, I am going to apply the same KVL, KCL, or in one step we can solve the answer KCL and KVL only. Right, so we have got the 2 ampere. Now we are going to verify it. For example, it is a 3 ampere. Let this current is I, capital I. This current will become what? 3 minus I. Now here, this is I. So what is the current here? Capital I minus small I. This current will become 3 minus I, same. This is 3, but this is I, plus minus, same KVL, but with battery. So when again, when we are applying the KVL in this loop, it will become 4 times of I minus I, plus 12, this is the plus 12, minus 3 times of I is equal to what? 0 in this loop. Then you will get 4I minus 7 small I plus 12 is equal to 0. So you have this first equation, right? In first equation you can write 7I minus 4 capital I is equal to what? 12. So we can write, this is the first equation, this is the second equation. If you have any doubt in this equation, you can give the number of equation, first, second or third. Right? Second, again you can apply the loop here from this point. This is the plus minus, this is plus minus. So you can write, go like this, 4 times of I minus I, 4 times of I minus I plus 24 minus 8 times of 3 minus I plus 4 times of I is equal to what? 0. Now, 2 unknowns, 2 equations, we have to find the small I. It will become 4I minus 4I plus 24 minus 24 plus 8I plus 4I is equal to 0. This 24, that 24 cancel out, and you will get the 4 plus 8 plus 4, that is the 8 plus 4 plus 4, 16I minus 4I is equal to 0. So what is the I is equal to 4 by 16 times of I, that is I, small I, that is by 4. So it is the equation number 4, it is the equation number 5, it is the equation number 6, and that is the equation number 7. If you have any doubt, then you can ask. Then finally put the value in what? This equation. You will get 7I minus 4 into 4 divided by 16I is equal to 12. Okay. This is it will become 6I is equal to 12. So what is the I is equal to 2 ampere. We are getting the same answer. 2 ampere. So what is the use of the superposition theorem? Just we are making the question very, very lengthy with the help of what? Superposition theorem. Are you getting my point, everyone? Right? So you are getting the same answer, I is equal to 2 ampere, and previously you have got the same answer, I is equal to 2 ampere. Means when we, but in this diagram, we can't say what is the effect of 24 volt battery, what is the effect of 12 volt battery, what is the effect of 3 ampere current source. But with the help of superposition, it is a linear circuit. We can give this 12 volt battery will provide 2 ampere, this 24 volt battery will give minus 1 ampere, this current source will give what? 1 ampere, and that's why the resultant current. And what is the effect? Which one is the dominant? 12 volt effect of the 12 volt battery is dominant magnitude wise. They are in opposite direction, they will cancel each other and so on. So we can conclude with the help of superposition theorem. Any doubt? Because we have verified the answer. We are getting the same answer, 2 ampere, or with the help of superposition again we are getting the same answer, 2 ampere. This is I3 is 1 ampere, I2 is minus 1 ampere, I1 is the 2 ampere, and that's why 2 minus 1 plus 1, minus 1 plus 1 cancel out, and 2 ampere is the answer. Now it is clear. Now it is clear. देखो एक क्वेश्चन में सुपरपोजिशन में अब आपको समझ में आ गया कि भाई सुपरपोजिशन थ्योरम पे क्वेश्चन क्यों नहीं आते. Because we can solve that particular question by using the nodal mesh, KCL, KVL. No doubt. I'm going for next question. तो आपने देखा ना कितने वेज हैं उसको सॉल्व करने के, डिफरेंट वेज वी हैव टू सॉल्व दैट पर्टिकुलर क्वेश्चन. 1 minute. If you have solved the question, then you will get the idea what is the mistake here. Okay. Okay. Give me 1 minute. Now, next question. Now find I in the figure using the superposition theorem. So now I think now it is easy. I am giving you the second trick. Sometimes we are making the I1 0, I2 0. You can make any one 0. For example, you want to get the effect of only 4 ampere current. What is the effect of the 4 ampere current? Then you can make it what short circuit, you can make it short circuit. And then you can find out what is the effect of 4 ampere so that you can calculate the I. Or otherwise individually you can make it short circuit, make it short circuit. First, but this type of questions you can directly solve For example, let this current is I. This is the I. This is the I. Now this is the 4 ampere. So what is the current here? I minus 4. Because at this point you can apply the KCL. So it will become I. So it will become I minus 4. Again it will become I. I minus 4 plus I, it is I. Same current will flow like this. So we have to apply only one KCL. One KVL and one, already we have applied the KCL at this point. Incoming I, outgoing, again incoming I, and so on. Now write down the KVL. This is the minus 16 plus 6I plus 2 times of I minus 4 plus 8I plus 12 is equal to what? 0. So minus 16, 6I, 2 times of I minus 4, 8I plus 12 is equal to 0. Then it will become 6 plus 2, 8, 8 plus 8, 16. Okay, now 6 plus 2, 8, 8 plus 8, 16I. And this is the 16 minus 8. Minus 16 minus 8, it will become minus 24. Minus 24 plus 12 is minus 12. On right side, it will become plus 12. What is the I? I is the 12 by 16. That is nothing but 3 by 4 ampere. Check my calculation and so on. So with the help of this KCL and KVL, in one step you can find the answer, that is a 3 by 4. Okay. Then superposition theorem. Okay. Yes. You can loop 3. There is a current source. Always remember, with current source we can't write the KVL. We can't write the KVL, and that's why we have used these 2 loops. You are asking question, sir. So this is the, and that is the second loop. Because here it is a current source, we can't write the KVL here. Right? And that's why we have used this loop and this loop only. Then, so guys, just I am giving you the hint. Superposition theorem means you have to draw the 3 diagrams. First, second and third. First, make it 0 means open circuit. Open circuit. Okay, make it short circuit. And this is called I1. Find the I1. First diagram. So this is a very, very simple. 6 plus 2, 8 plus 8, 16. 16 divided by 16. What is the I1? 1 ampere. 1 ampere. 8 plus 8, 16, 1 ampere. Then similarly, you can make this short circuit. This is short circuit. Now what is the I2? Because of 4 ampere current source, right? So what is the I2 because of the 4 ampere current source? How you can find? You can apply the current division rule, right? Or you can write a KVL like this. Just I am giving you the hint. This is the 4 ampere. This is become 4 minus I2. 4 minus I2 from this loop. This is also, watch this. This is the 4. So this is the 4 is going here. And that's why it will become minus I2. Minus I2 in this loop. In opposite direction. So this is the minus I2. So what is this current? Or you can say this is I2. So or in this way easily you can write that this is I2. Here it is a 4. That's why it will become I2 minus 4. or this is what again I2 and so on, and then write down the KVL. 6 plus 2 plus 8, 8 plus 8, 16 I2 minus 8, 4 into 2, 8, 4 into 2, 8, and 6 plus 2 plus 8, 16 I2, right, is equal to what? 0. So what is the I2 is equal to 8 by 16, that is 0.5. 0.5 ampere. This is a very quickly you have to solve. Then third one, again it will act as what? Open circuit. And this will act as short circuit, right? Now what is the current? Because of the 12, that is in opposite direction, that's why it is negative. And what is the resistor? 6 plus 2, 8, 16. So what is the I is equal to minus 12 by 16. This is the I3. 6 plus 2 plus 8, and this is in opposite direction, and that will become minus 4 by 3 by 4. 3 by 4. Now watch. 1 ampere I1, I2 and I3. So what is the total? 1 ampere, 0.5, minus 0.75. So 1.5 minus 0.75 is 0.75. 0.75 is nothing but 3 by 4 ampere. We are getting the same answer. But again, superposition theorem, lengthy 3 steps we are getting the answer, or in 1 step already we have the answer in 1 steps. That is the 3 by 4 here. But what is the effect of the 16 volt battery? 1 ampere. What is the effect of the 4 ampere current source? 0.5 ampere. What is the effect of the 12 volt battery? Minus 3 by 4 ampere. And overall result is what? 3 by 4 ampere. So I think more than sufficient question we have solved on what? Superposition theorem, guys. Okay. So this is all about the superposition theorem. Now we will solve questions on Thevenins and Nortons. I have given assignments. Any doubts, then you can ask. Then if you are going to watch the recorded lectures, so first of all pause the video, try to solve the questions. Okay, try to solve that question, pause video, and then go for what? Solution. Or if you are watching the live lecture, then try to solve it. Try to solve this question. I have given assignment in my paid classes to everyone. Bataiye, what is the answer? Okay. Give me 1 minute. Then tell me, what is the answer? Now, using the Thevenin's theorem, find the equivalent circuit to the left of the terminal in the circuit of the figure. Then find I. So guys, if you want to solve this question, you have to find the Thevenin's equivalent across A and B. That is RTH and that is the VTH. VTH across A and B. Then you can connect this 1 ohm resistor and you can find I. I will become VTH upon RTH plus 1 ohm. At this point you have to find the RTH, at this point you have to find the VTH. Very, very simple question. Now, watch this. First, what is the VTH? First of all, make it what? Open circuit. This one open. VTH means open circuit voltage. In previous class already I have given VOC. This is called VTH. Open circuit means this current is 0. Now, if you want to find the VOC, how we can find? This is the VOC. This voltage is what? VOC. Then the total resistance at this point is what? 6 and 4. So first of all, you can write the Vx here. Let I am going to apply the nodal equation at this node. So these two resistors are in series. And finally, we will find the current here, Ix. So what is the current Ix? Vx upon 6 plus 4, that is the Vx upon 10. If you have the Ix, then you can directly find the VOC. VOC is nothing but 4 times of Ix. 4 times of Ix. So we have to apply the KCL at this point only. So what is the incoming current? 3. What are the outgoing current? Vx minus 18 by 6. Vx by 10. This is from this point to this point, total resistance is 10. Now you can choose 30 as a LCM. This will become 5Vx minus 90 plus 3Vx is equal to 3, that is 90, is equal to 8Vx minus 90, that will become Vx is equal to 180 divided by 8. 180 divided by 8 volt. So what is the Ix? That is the Vx by 10. So Ix will become, or this is the 4 times of Ix. Vx by 10, that will become 18 by 8. And then what is the VOC? 4 into 18 by 8. 4 times of Ix, and that's why it will become 9 volt. That is the answer. This is the one way to solve, guys. One way to solve. Is there any other method? 9 volt. We have applied the nodal equation, then that is the case. Or once you have the Vx, you can also apply the voltage divisor rule from this point to this point, that is the Vx. So again you will get the VOC is equal to 4 upon 6 plus 4 Vx, that is 4 Vx upon 10. You will get the same answer, right? This is the one way to solve the question. Is there any other way? Yes. What is the another way? Mesh analysis, super mesh analysis. Just I am giving you the super mesh analysis. Super mesh means if you want to find this VOC, first of all make it open circuit. Now you can choose a current here, like this is the I1, this is the I1 and this is the I2. Okay, so what is the VOC? VOC will become 4 times of I2. 4 times of I2. Now super mesh means what? What is the relation between I1 and I2? This is in downward, this is in upward. So what is the current in this branch? I2 minus I1. So I2 minus I1 is equal to what? 3. So what is the I1 is equal to I2 minus 3. This is the like that first equation, second equation, third. If you have any doubt, then you can give the number of equation. So this is the upward direction, that is the downward direction. So it will become what? I1 is equal to I2 minus I1 is equal to 3, and from that you will get the I1 is equal to I2 minus 3. Now you can write a super mesh equation. What is the super mesh equation? You can directly write a KVL from this side to this side to this side. This point, from this point to this point, you can write a KVL, and that will become minus 18 minus 18 plus 6I1 plus 6 plus 4 10 I2 is equal to 0. What is the I1? I2 minus 3. So it will become 6 times of I2 minus 3 plus 10 I2 is equal to 18, and that's why 6 plus 10 16 times of I2 minus 18 is equal to 18. I2 will become 36 times by 16, that is nothing but 9 by 4 ampere. 9 by 4 ampere. So what is the VOC? 4 times of I2. So what I have done, just practice. I am solving the same question by 2 different methods. Quickly I am getting the command over super mesh analysis, or what division, voltage division rule, and so on. So in this way you have, if you have started your preparation and you want to get the command, solve same questions by what different methods: mesh analysis, super mesh analysis, nodal analysis, KCL, KVL, and so on. Then guys, automatically you will get the command over this particular topic, guys. Okay, ये हो जाता है इतना easy. अब VOC 9 volt. So what is the RTH? RTH means the current source will act as open circuit, voltage source will act as short circuit. What is the RTH here? This will act as open circuit, this will act as short circuit, and if you want to find the RTH here, this is short circuited. What is the RTH at this point? What is the resistance from this? So RTH is nothing but 6 plus 6, 12, and 4 are in parallel. 12 parallel is nothing but 3 ohm. Now you have the RTH, you have the VTH. What is the current across 1 ohm resistor? The current will become 9 by 4 ohm. Current is 9 by 4 ohm. So this is the Thevenins. This is what? Thevenins, guys. 9 by 4 ohm. आपको फाइंड करना था व्हाट इज द करंट टू द 1 ohm रजिस्टर. तो फाइनली गेट द VTH एंड RTH एंड देन कनेक्ट द 1 ohm रजिस्टर एंड यू विल गेट द वैल्यू. एनी डाउट? Just for you, I am giving you the reference. If you find any difficulty in particular equation, then directly you can ask her equation number 3, equation number 6, equation number 8. That is a particular question. What is the doubt? तो आप पूछ सकते हो कुछ भी, मेरे को इक्वेशन नंबर बस भेजो कि सर यहाँ पे इस स्लाइड में ये इस क्वेश्चन में प्रॉब्लम है, तो मैं आपको बताऊंगा राइट कि कैसे लिखे. अगर कुछ आपको लगता है कि सर से कैलकुलेशन मिस्टेक हो गई है तो ज़रूर इन्फॉर्म कीजिए. योर सजेशन इज ऑलवेज वेलकम. ये आ गया 9 वोल्ट, ये 9/4. तो दिस इज द थेवेनिन्स. ओके, थेवेनिन्स इक्विवेलेंट. नॉर्टन्स के बारे में बात करेंगे. दिस इज द अनदर क्वेश्चन फ्रॉम स्टैंडर्ड टेक्स्ट बुक. फाइंड द नॉर्टन्स इक्विवेलेंट सर्किट ऑफ द इन द फिगर एट टर्मिनल A and B. Norton's equivalent. So we have practiced lots of question in during classes, paid classes. I think you have solved this question. Just I am giving you the solution. Find the Norton's equivalent circuit of the figure. What is the Norton's equivalent across this? Means you have to convert it into what? Single current source with a resistor in a series, in a parallel. This is A, this is B, this is called Norton's resistance, this is called Norton's current. Sometimes it is written as IS, RS. Single voltage source, single resistance. So what is the Norton's current? That is called a short circuit current. Short circuit current. Norton's current is a short circuit current. To make it short circuit. Now this 5 ohm is short circuited, so same ISC will pass through this, no current through the 5 ohm resistor. Why? Because the voltage across this 5 ohm is 0. Voltage across this 5 ohm is 0. That's why what is the current through the 5 ohm resistor? 0. Same ISC will pass. Same ISC will pass here. And now we are having the 2 ampere here, 2 ampere source. If this is the ISC, in this path this is the 2 ampere, so what is the current here? ISC minus 2. What is the current here? Again ISC. ISC minus 2 plus ISC. So this is the plus and minus. Now you can directly write the KVL and in one step you can find what ISC. To find the ISC, just write down the KVL from this point to this point to this point and so on. Already we have applied the KCL at this point. Now, what is this? 8 times of ISC. Then this is 0. 8 times of ISC minus 12. This is the minus 12 plus 4 times of ISC minus 2 is equal to 0. Then it will become 16 ISC minus 12 plus 4 ISC minus 8 is equal to 0. Then 8 and 20, this will become what? 20 ISC. 20 ISC is equal to 20 and that's why ISC is equal to what? 1 ampere. Norton's current or short circuit current, this is nothing but Norton's current is 1 ampere. Okay, have you solved this question? First, second, third equation. If you have any doubt in any equation, then please give me the comments. Solve करो लेकिन खुद से. Use your rough copy, pen and calculator. पूरा full excitation के साथ solve कीजिए. What I have done, just a short circuit current, because it is short circuited. What is the current through the 5 ohm resistor? 0. Same current will flow I have applied the KCL at this point. This is the 2 ampere, and that's why what is the current in this branch? ISC minus 2. Again, it will become ISC. I have applied the KVL, and in one step, I have find the ISC. Norton's current. Norton's current. Then, Norton's current. What is the Norton's resistance then? Norton's resistance means current source will act as open circuit. This current source will act as open circuit. Voltage source will act as short circuit. What is the resistance seen from this terminal? This is called Norton's. So this 8, this 4 and this, because it is a short circuit 8. This 8, this 4, this 8, it is in series. So 8 plus 8, 16 plus 4, 20. 20 parallel with 5. And that is become Norton's resistance. What is the 20 parallel with 5? Already I have given, that is the 4 ampere. Otherwise you can find 20 into 5 plus 20 plus 5. 100 by 25, that is 4 ampere, 4 ohm. That is the Norton's equivalent. 1 ampere, 4 ohm. Finished? Okay. 4 ohm. ये है कहानी. Find a Norton's equivalent circuit of in the figure across A and B. So, if you are just practicing the question, because what is the new in this? This terminal is not grounded, guys. We have the 8 ohm resistor here. In downward, we have the 8 ohm. That is the different thing about this particular question. This is the differentiator, 8 ohm connected here. And you have to find the Norton's equivalent across this resistor. Take care of that. Take care of this. Normally, students are missing this resistor. Easy. Pause karo, watch the recorded lecture and try to solve. Pause the video, solve it, then go for solution. So this is the fourth equivalent, 1, 2, 3 and 4. So this is the question, 2 questions, Thevenin's and Norton's on what independent sources. Sir, which question? Sir, is question में loop 3 को. Tell me in which question you have doubt. Okay. Here, first of all, find the Norton's equivalent circuit of the figure. Means you have to find the short circuit current and what? Resistance across terminal A and B. What I have done, just make the circuit short circuit. Therefore, what is the voltage drop across the 5 ohm resistor? It will become 0. Okay, here. there is no current through this. Same ISC will flow from this point to this point, from this point, and which is the 2 ampere. That's why it will become ISC minus 2. Write down the KVL from this point to this point. It will become 8 ISC. Again it will become 8 ISC minus 12, and then 4 times of ISC minus 2, and then find the doubts and you will get the answer ISC, that is equal to 1 ampere, guys. This is the ISC is equal to IN is equal to 1 ampere. Calculation is your part. And then to find the resistance, make the voltage source short circuit, current source open circuit. You will get this. This is the 8 plus 4 plus 8, 20, and 20 and 5 are in parallel, and that's why we are getting the 4 ohm. So what is the 1 ampere and 4 ohm, that is in parallel. This is the result. Okay. Thevenin's, Norton's. Now, next question. Obtain the Thevenin's equivalent. अब आप इसको बनाओगे. अब ना मैंने बहुत क्वेश्चन बताया, तो all the students, these are the, अब you can solve it. You can solve it. Very, very easy question on Thevenin's. Now we will solve some questions on what dependent sources. Watch this. Find the Thevenin's equivalent of the circuit in figure at terminal A and B. If you want the Thevenin's equivalent, we have dependent source here, 2Vx. Dependent source Vx, 2Vx, and you have to find the Thevenin's equivalent across A and B. We have to find the VOC, we have to find the RTH, both. So what is the effect of this? Now, how we can solve this question? Thevenin's equivalent. Thevenin's equivalent means what? You have to find the VOC and ISC. VOC and ISC. Why ISC? To find the RTH. Because RTH is equal to VOC upon ISC. This is the terminal A, this is the terminal B. Now, if you want to find the VOC, remember this is the open circuit. Always remember, this current is 0. So what is the drop across the 2 ohm resistor? 0, and that's why the voltage from this point to this point is also VOC. VOC from this point to this point, it is also VOC because there is no drop across 2 ohm resistor. And guys, remember, if you have any resistor across the voltage source, whether it is a dependent or independent, it is a voltage controlled voltage source. So you can remove the 2 ohm resistor. You can remove the 2 ohm resistor here. If you are going to remove the 2 ohm resistor, yes, why? Because it is connected in a parallel with the voltage source. You can easily remove it. Now, how we can find the VOC? Watch it carefully. This is the Vx, this is the 2Vx. From this point to this point, this is the 5 ampere current source. Okay. Now, if it is a 5 ampere current source, what is the current in this loop? You can directly say the current in this loop is Vx by 4. Because that voltage is Vx. So what is the current here? Vx by 4. So what is the current here? The current will become 5 minus Vx by 4. 5 minus Vx by 4, and the same current will pass here. Same current, 5 minus Vx by 4, because what is the current here? 0. So what is the current here? 5 minus Vx by 4. Now, what is the relation between VOC and Vx? If you want to find out what is the relation between VOC and Vx, then very simple thing. Watch it carefully. What is the voltage at this point? VOC. From this point, what is the voltage? 2Vx. What is the voltage? Vx. So what is the VOC is equal to? VOC is equal to 2Vx plus Vx. It will become 3Vx. So what is the Vx is equal to? VOC by 3. Vx is equal to VOC by 3. So you can write VOC is equal to 6 times of 5 minus Vx by 4. And again you can write VOC is equal to 6, 5 minus, this is the VOC by 3, so it will become VOC by what? 12. Then you can write VOC is equal to 30 minus VOC by 4, VOC by 2. 6 multiplied, that is the VOC by, so it will become 3 VOC by 2 is equal to 30. So VOC is equal to 2 by 3 times of 30, 20 volt. 20 volt is the value of the VOC. That is the one way. I will give you the another way to solve this. So what is the one way? Let this current is 5 ampere, so this will become Vx by 4. So what is the current? 5 minus Vx by 4, 5 minus Vx by 4. So you can write the VOC is equal to 6 times of 5 minus Vx by 4. Now, what is the relation between the Vx and VOC? So from this you can get the relation, because from this point to up to ground, it is the 2Vx and that is the Vx. So what is the total relation? 2Vx plus Vx, it will become 3Vx. So you can replace the Vx by VOC by 3. Once you are going to replace the VOC, you will get this equation and answer. Okay. Please watch it carefully. This is VOC. Always remember, when we are making it open circuit, means in this branch there is no current, and that's why this voltage is transferred here. Okay. If there is any other way to find the VOC? Yes, we can apply what? Super mesh or super nodal analysis. Sorry, super nodal. What is the super nodal analysis? First of all, remove this 2 ohm resistor, because it is connected parallel to a voltage source. You can remove it. Now, what is the voltage at this point? VOC. This is open circuit, that's why the voltage at this point is also VOC. This is Vx. This is VOC, this is Vx. At this node voltage is VOC, at this node Vx. We can't apply the direct nodal, so we have to apply the super nodal, because there is a one voltage source between these two nodes. This voltage is VOC, this voltage is Vx, is equal to what? 2Vx. So what is the relation between VOC and Vx? VOC is equal to 3 times of Vx. Or you can write the Vx is equal to what? VOC by 3. Both are correct. Now you have to apply the super nodal. Super nodal means super nodal analysis. So at the two nodes we are applying the KCL. So what is the incoming current? 3, 5 is equal to what is the outgoing current? Vx by 4 plus at this node what is the outgoing current? VOC by 6. Finished. This is the VOC minus 0 by 6. What is the current in this branch? 0. What is the Vx? VOC by 3. So you can write VOC by 3 means 12 plus VOC by 6 You can take 12 as a LCM. It will become VOC plus 2 VOC is equal to 5. 12 into 5, 60 is equal to 3 VOC. So what is the VOC is equal to 60 by 3, 20 volt. This is called supernodal, right? तो देखो मैंने दो मेथड से हर क्वेश्चन को मैं सॉल्व कर रहा हूं. सुपरनोडल इक्वेशन वी हैव सॉल्व. So this is the equation. Just now, this is the first of all I will explain this. Supernodal, remember, if you have any resistor parallel to what voltage source, you can remove it. Then this voltage, because there is no current through the 2 ohm resistor, that's why the voltage at this point and this same VOC, and this is the Vx. Now VOC minus Vx is equal to what? 2 Vx, and that's why you will get this equation. And then Vx is VOC, and then apply the nodal. What is the incoming current? 5. Outgoing current Vx minus 0 by 4. At this node VOC minus 0 by 6, because in this branch there is no current. Finished equation and you will get the answer. In a previous case, I have applied the KVL from this point to this point. From this point to this point. Just to get the relation. So VOC is equal to what? 2Vx plus Vx, 3Vx. This is the first equation. VOC is equal to 3Vx, and that's why Vx is equal to VOC by 3. Okay. So this is the question. Now we have to find the RTH also, na? Because there is a dependent sources. To find the RTH, first of all, because we have the VOC 20 volt, so you can use a direct method, that is called what? Short circuit. Short circuit the output terminal. If you are going to make it short circuit, this is called short circuit current. Remember, short circuit means what? This is the short circuited node. This is 0, and that's why it will become 0. Now you can again apply. Let this voltage is V2, this voltage is Vx. So you can also write Vy. Vx and Vy. Then remember, if you have the resistor parallel to that, you can remove it. Again same relation, supernodal. What is the relation between Vx and Vy? Vy minus Vx is equal to 2Vx. So what is the Vy is equal to 3Vx, or you can write Vx is equal to what? Vy by 3. Once you have the Vy by 2 will give you the ISC, and that's why I am going to find the Vy. Now write down the supernodal. What is the incoming current? 5. What is the outgoing current? Vx by 4. What is the outgoing current? Vy by 6. Vy minus 0 by 2. Now you can replace the Vx by what? Vy by 3. When we are going to replace it, Vy by 6, Vy by 3 means it will become Vy by 12, Vy by 6, Vy by 2, 12, Vy, 2 Vy, 6 Vy. This is the 60, and here you will get the 9. What is the Vy? 60 by 9, and that is 20 by 3 volt. What is the ISC, guys? ISC is Vy minus 0 by 2. You will get the ISC is equal to Vy by 2, that is the 10 by 3 ampere. 10 by 3 ampere is the short circuit current, and short circuit current is nothing but Norton's current. So we have actually find a Norton's current. What I have done, first of all, make it short circuit. Then we are going to apply the super nodal. Vy minus Vx is equal to 2Vx. Vy is equal to 3Vx. So Vx is equal to y by 3. Super nodal means what is the incoming current 5, what is the outgoing current Vx minus 0 by 4. Now at this node Vy minus 0 by 6, Vy minus 0 by 2. Then Vx is replaced by Vy by 3 and that's why it will become Vy by 12. Then you can take 12 as the LCM. It will become Vy, it will become 2Vy, it will become 6Vy. 12 into 5, 60. And that is the 9Vy. 1, 2, 3, 9. And Vy will become 60 by 9. That is the 10. When it is divided by 3, 20 divided by 3. And then it is the ISC y by 2. Y minus 0 by 2. You will get the 10 by 3 ampere short circuit current, Norton's current. If you have the ISC, if you have the VOC, then you can find the RTH, guys. RTH or RN are same, Norton's resistance are same, VOC upon ISC. So what is the VOC? 20 volt. What is the ISC? 10 by 3. 6 ohm. Six ohm. So this is the 6 ohm, is the VOC. VOC nahi, RN. VOC is the 20, ISC is the 10 by 3, so it will become 6 ohm. Now, up to this point, any doubt in any equation? 1, 2, 3. How to find the ISC? 4, 5, 6, 7, 8, 9. So in my paid classes, you have the opportunity to ask your doubts, guys. कि सर इस नंबर की स्लाइड में ये आपको प्रॉब्लम है, इस इक्वेशन में, इस क्वेश्चन में 1, 2, 3, 4, 5, 6, 7, 8, 9, equation number 6, equation number 8, equation number 9. If you have any difficulty, then you can ask. Okay? लेकिन पहले क्वेश्चन पूछने से पहले try to solve it on what? Rough pages. You have access to what? Recorded lectures. Go through the recorded lectures. And you can increase the speed also, 1.5 to 2x and so on. And then if you find any difficulty, then inform me. Now, is there any other method to solve the RTH? Yes, we have other method to solve the RTH. What is the method? Suppose you want to find the RTH, you can connect a 1 volt battery here, external battery. But remember, in that case, you have to make it what? Open circuit. All independent sources will be 0. That's why I make it what? Open circuit. Remove it. And then, what is the RTH? Or Rn is nothing but 1 by I. What is I? Current given by this battery. V by I or 1 by I. This is the equation number 1. Now again, if you want to find 1 by I, this resistor is connected parallel to voltage source. You can remove it. You can remove this resistor. Okay. Now what is the procedure so that you can find the 1 by I? Then watch the diagram carefully, guys. Always watch the diagram carefully. You can watch. This voltage is Vx, this voltage is also Vx, so Vx, 2Vx plus Vx, so what is the voltage at this point? 3Vx. You have to write like this. What is the voltage at this point? This is the Vx, this is the Vx, write down the KVL from this point to this point, this voltage will become 3Vx. From this point to this point to this point, it will become 3Vx. 3Vx by 6, what is the voltage here? What is the current? 3Vx by 6 is become Vx by 2. 3Vx by 6, it will become Vx by 2. And this is the current. So what is the current here? I minus Vx by 2. This is the current, downward Vx by 2. So this is the I minus Vx by 2. तो ये हो गया करंट डिस्ट्रीब्यूशन. You can solve by any type of method, but just I am giving you the shortcut. Now, if this is the Vx by 2, this will become I minus Vx by 2. Then guys, you can write a KVL from this point to this point. And remember, same current will flow I minus Vx by 2 here. So you first of all write what is the Vx is equal to. This is the Vx is equal to 4 times of I minus Vx by 2. You know, Vx is equal to 4 times of I minus Vx by 2. That's why you can write Vx is equal to 4I minus 2Vx. And from that you will get the 3Vx is equal to 4I. 3Vx is equal to 4I. So what is the Vx is equal to? 4 by 3I. 4 by 3I. Now, you can write a equation. You can also write a KVL in this loop only. You can also write the KVL in this loop or up to this point. No need to go up to like this. If you are writing the KVL, it is a very easy one. Minus 1, this is the minus 1, plus 2 times of I, plus 3Vx. Finished. This is the KVL. What is the Vx? 4 by 3I. So it will become 2I plus 3 into 4 by 3I is equal to 1. And that is 4 plus 2, 6I is equal to 1. So what is the 1 by I? 6 ohm. Because it is nothing but RTH. Yes, tell me, all the students tell me, we are getting the same answer, yes or no? We are getting the same answer. If only the RTH is required, then you can go through this. First of all, make the current source open circuit, remove the resistor because it is connected parallel to that, and then up to this point, this voltage is 2Vx, this voltage is 2Vx, that's why this voltage is 3Vx. What is the current here? 3Vx by 6. What is the current here? I minus Vx by 2. This is I, this is the Vx by 2, and you will get the relation between I and Vx by 2 and directly apply the KVL up to this point and you will get the answer. 6 ohm. तो देखो, प्रैक्टिस करने से, बार बार क्वेश्चन सॉल्व करने से एक्चुअली अप्रोच आती कि आपको कैसे क्वेश्चंस बनाना है, हाउ वी कैन अप्रोच ऑल दिस क्वेश्चंस एंड सो ऑन. दिस इज क्लियर. इक्वेशन नंबर 6, 7, 8 and what 9. This is the 4th and so on. These are the equations. Find RTH. So we have find the Thevenin's equivalent, Norton's equivalent, both, because we have the ISC, VOC, RTH, RN. RTH and RN are same, 6 ohm. This is the 6 ohm. We have find what? Thevenin's equivalent. क्या, what is the Thevenin's equivalent? 6 ohm, 20 volt. We have the Norton's equivalent. This is 10 by 3 and this is the 6 ohm cross A and B. And we can verify these are the source transformable pair, means from Thevenin's you can get the Norton's. How? What is the relation between the Thevenin's voltage and Norton current? Norton current is Thevenin's voltage 20 divided by 6, you will get the answer 10 by 3 ampere. Norton's resistance is equal to what? Thevenin's resistance. Source transformable pair. From Thevenin's you can get Norton, from Norton you can get the Thevenin's. You can verify it. You can verify it. Okay, which equation? Equation number 6. Okay. In this diagram, in this slide, na? This is the -1. Watch, I have write the KVL up to this point only. This point, bus. Watch it. What is the voltage? -1 plus 2ix, and what is the voltage of this node with respect to ground? 3vx. This is finished. -1 plus 2i plus 3vx. And that is the equation number 6. Now you can arrange it. Okay. Why 3? You can go from this point to this point. Now already you have done. So they go -1 plus 2i plus 2vx plus vx, or otherwise you can stop here because already we have the node voltage 3vx. -1 2i plus 3vx khatam. Or otherwise you can go like this up to this point. -1 plus 2i plus 2vx plus 4i 4 plus vx. What is the voltage at this point? Vx. -1 2i 2vx plus vx. Okay. Now one question on maximum power transfer. We will arrange session next week. Again we will arrange session on what? Question practice. पहले आप बताओ तो सही. Watch this. Maximum power transfer theorem. Looking into the terminal of the circuit shown in the figure, from the right, determine the Thevenin's equivalent. What value of RL produces the maximum power to RL? What value of RL? We have to use the maximum power transfer theorem. What is the maximum power transfer theorem? First of all, find the VTH and RTH. Okay, first of all, find the VTH and RTH, and what should be the value of RTH? RL. RTH. RL should be equal to what? RTH to get the maximum power transfer theorem. Loop 2 में 6 ohm and Vx by 2 ohm. Okay, we are getting the same thing. We are getting the gains. We will get the same thing. Like, for example, already है ना, KVL will satisfy for all the loops. KVL will satisfy for all the loops. 1 minute. If you are asking the doubt, I am just giving you the answer. Now watch it. Suppose you are going to write in this loop, again you will get the same answer. Sir, you are asking about the equation number 6, how you are getting the equation number 6? So there are multiple ways. You can also write a KVL in this loop. -1 plus 2i plus 6 times of Vx by 2. Again you will get the same, yes or no? -1 plus 2i plus 6 times of Vx by 2. You will get the same equation number 6, yes? What is the problem here? Okay. So, why, how we are reading this is the Vx by 2? Because that voltage is Vx by 2. How we can say this voltage is Vx by 2? Already we have applied the KVL in this loop. So, in this loop, in everywhere KVL and KCL should satisfy. These are the basic law. Okay. In a closed loop KVL or in branches, in nodes, we have to satisfy the KCL. To try to solve as many as question. देखो easy हो जाएगा अभी 2 + 2 जैसा एकदम तेजी से कुछ भी लगा दो उल्टा सीधा. आपको एक बताता हूँ बात, फिर उसके बाद आगे बढ़ेंगे. ये देखो एक बात बताओ, नेटवर्क मीन्स व्हाट? प्रैक्टिस. प्रैक्टिस मीन्स व्हाट? व्हाट इज द 2 + 2? आप बोलोगे 4. व्हाट इज द 2 + 3? यू कैन से 5. 2 × 3 यू कैन से 6. तो सो इजी ना, सो इजी. एंड नींद में भी उठा दिए, कोई बोला अरे बताओ क्या होगा, तो बोलेंगे यस सर 2 + 2 = 4. व्हाई? प्रैक्टिस है ना, बहुत प्रैक्टिस करवा दी आपको बचपन में. तो टेल मी. और ऐसा भी होना चाहिए. व्हाट इज दिस? बोलोगे सर ट्रायंगल, राइट. अब फिर व्हाट इज दिस? ट्रायंगल. नाउ व्हाट इज दिस? Triangle. What is this? Triangle, right? Then just I am rotating. What is this? Triangle. So if you have the command, उसको किसी भी डायरेक्शन से चालू करें, above to below, below to above, you will get the same answer. This is called triangle bingo. ITC bingo एक आया था ना, चिप्स, अचारी मस्ती, उसमें होता है ना, कैसे भी देखो आपको ट्रायंगल दिखाई देना चाहिए. ओके, एंड दैट इज द केस. नाउ वॉच इट केयरफुली. Looking into the terminal of the figure, circuit shown in the figure from the right, determine the Thevenin sequence. That is the last question. फिर again next week again we will practice more and more question. Get the command over that. Okay. So I have given the number of assignments. Try to solve those questions. Looking into the terminals of the circuit shown in the figure from the right, determine the Thevenin equivalent circuit. What value of RL produces the maximum power? So first of all, find the VTH, then RTH, and then RL should be equal to what? RTH. Then Thevenin equivalent, if you want to find, remember, what is the open circuit voltage? It is an open circuit, and that's why I is equal to 0. If this I is equal to 0, because it is open circuit, this I is 0. So what about this is a current control voltage source? This will also become 0, and that's why it is short circuited. I is 0, this is 0. What is the current through 10 ohm resistor? 0. So what is the voltage when I am writing the VOC is nothing but 10 volt. Quickly you can say it is a 10 volt. Why? Because there is a one battery, there is no current through 10 ohm. This is depends upon the I, it will become 0, and that's why this answer is what? 10 volt. Answer is 10 volt. This is called VOC. Then if you want to find the RTH, then remember you can directly make it what? Short circuit. I is nothing but ISC, so this will also become ISC. This is ISC. This current is ISC. Now directly you can write a KVL. It will become minus 10 plus 10 times of ISC minus 20 times of ISC. Watch it carefully, minus 20 times of ISC, and that it will become 0. What is this? Minus 10 times of ISC is equal to 10. What is the ISC is equal to? Minus 1. Minus 1. Now what is the Thevenin's resistance? Negative here. VOC upon ISC. So what is the VOC? 10 volt. What is the ISC? Minus 1 volt. So what is the Thevenin's resistance? Minus 10 ohm. Minus 10 ohm. Yes, it is possible to get the negative Thevenin's resistance. Negative Thevenin's resistance. Now, if this is the negative Thevenin's resistance, so what is the meaning of that? If you have the negative Thevenin's resistance, so what should be the value of RL so that you will get the maximum power? That is the magnitude of that. That is what? Magnitude of that. In that case, if you have the Thevenin's resistance negative, this is RL, this is the passive resistor, but it is negative. And this is what? 10 volt. So RL should be the magnitude of RTH, that is what? 10. So first of all, get the idea what is the current here? VTH upon RTH plus RL. Guys, when the current will be maximum? VTH is 10 volt, this is the minus 10. So what should be the value of the RL? Plus 10. What is the current? Infinite. And you will get the infinite power here. So that is the maximum power. Are you getting my point, everyone? I square into RL. This is I. So if we are getting the RTH negative, don't worry about that. Yes, you can get the RTH negative. In case of amplifier, in case of oscillator, we are getting the RTH negative. So no problem, and that is the case. So this is a unique question where the RTH is negative. So first of all, find the VOC. Then second, find the ISC. And then you can find the RTH. And then we can verify it. If we are having a negative, then the power will be maximum, that is infinite, and the current is infinity also. Then RL, passive resistor, and that's why it should be positive. So RL is the magnitude of RTH. And in this way you can get the infinite current. If there is any other method to find the RTH, yes. You can make it what? 1 volt battery. Let this is 1 volt battery. And let this is the short circuited. Let this current is Ix. So what is the RTH? 1 by Ix. This is the 1 volt battery, and what is the current given by that? Ix. So what is the relation between I and Ix? Ix is equal to minus I, and that's why it will become minus 20 times of Ix. Write down the KVL. So you can write minus 1. This is a plus, but actually it is a minus. So you have to write the minus. This is the plus times of minus 20 Ix. Same current will flow Ix, 10 times of Ix. Is equal to what? 0. Then you will get minus 1 minus 10 times of Ix is equal to 0. This is minus 10 Ix is equal to 1. So what is the 1 by Ix? Same answer. Same answer you will get. Same answer. Make it what? Short circuit. Active sources, active independent sources, short circuit, but dependent source will be there. Like the 1 volt battery will give the current Ix, then RTH will become 1 by Ix. You will get the relation between I and Ix, that is the minus I. Replace it. Minus 20 Ix 20i is replaced by the minus 20ix, and then write down the KVL in this loop, and you will get the minus 10. So RTH is negative. Yes, it is possible. RTH negative is possible, guys. So hope you have enjoyed the session. Everyone, please, if you watching the recorded session, then first try to solve this question on what your copy with virtual calculator only, right? And then you have to download the virtual calculator. Virtual calculators are available. You can download on your mobile, on your laptop, and only use what virtual calculator, क्योंकि GATE में virtual calculator ही allowed है. And then solve it, practice it. If you have any doubts, then you can ask. Further, again, in between, I will take what number of sessions. I will upload the recorded sessions for you. Recorded sessions on previous year questions, to go through that. Okay then. तो ये पूरा आप लोगों को फैसिलिटी अवेलेबल है ऑन पेड क्लासेस. बिकॉज अब क्या करेंगे, आई एम गोइंग टू अपलोड द प्रीवियस ईयर क्वेश्चंस, important previous year questions from electronics, electrical and instrumentation, from the basics of the network, from the theorems of the network. Now 2 topics over. Tomorrow onwards we are going to start what new topics, right? New subject. जैसे अब अब तक क्या हो गया, नेटवर्क थ्योरम्स हो गया, बेसिक्स हो गए. We have dealt with what theorems with DC. There is also theorems with what AC signal. When we are dealing with the steady state analysis of AC signal, then again we will learn about the theorems. Okay, till then please practice all the questions. So tomorrow please watch the timing, right? कुछ भी होगा discussion, I will inform you. Okay then, thank you very much for attending the session, guys. Have a nice day.